Welcome to my math video debut. As promised, I will go through some of your homework problems with you and get things set up. So when we're looking at these problems, we are going to be calculating the double angles of sine and cosine, as well as the half angles of sine and cosine. And although we know where our original theta starts out, we need to figure out what quadrant double theta and what quadrant half theta will end up in to figure out the positive and negative value of sine and cosine. So let's start by drawing our quadrant. We want to understand where our theta is starting. So because it's between 90 and 180, we know that it's located in quadrant 2. And we want to go ahead and set up a right triangle to understand what this sine value is showing us. We know that the opposite side is 4, and we know the hypotenuse is 5. So the only unknown value here is going to be x. Now, we know that sine and cosine change signs depending on the quadrant. Both of them are positive in quadrant 1. Cosine is negative in quadrant 2, but sine is positive. They're both negative in quadrant 3. Cosine is positive in quadrant 4, and sine is negative in quadrant 4. So when we go to calculate sine 2 theta, cosine 2 theta, sine of theta divided by 2, and cosine of theta divided by 2, we need to know which one's going to be positive and which one's going to be negative. So let's start by doubling our theta. Let's think about 2 theta. If we know that theta starts out in quadrant 2, we want to figure out where double theta is going to end up. Let's pick one just to try it out. So let's imagine that our original theta was 100. If I double that, 2 theta is going to be 200, which is in quadrant 3. But if I choose a larger theta, let's say 170, doubling that value is 340, which puts us in quadrant 4. So we need to be able to understand which angles will double to quadrant 3 and which angles will double to quadrant 4. And the way to do that is to think about 270. That's this angle right here, and it's the dividing line between quadrant 3 and quadrant 4. So if I divide 270 by 2, that tells me that 135 is the cutoff of my original theta value. Anything bigger than 135 is going to end up in quadrant 4. Anything smaller than 135 is going to end up in quadrant 2. So we can kind of split it up into two cases. We have if our theta is between 90 and 135. Oh, sorry about that, guys. Let me erase that. Okay. If it's between 90 and 135, we know that this is going to be quadrant 3. And if it's between 135 and 180, we'll end up in quadrant 4. So what is going to change between quadrant 3 and quadrant 4? Well, if we take a look at what we had written about the sines, the only thing that's going to change is our cosine value. So what we can do is we can say that for double theta, this is going to be positive or negative. And that's kind of based on this condition, or the two conditions that we came up with down here. Sine, on the other hand, is going to be negative no matter what. So I'm just going to put a negative next to my sine double theta. Okay? The next thing that I want to think about is what's going to happen when I have theta divided by 2. What's going to happen when I take a theta in this quadrant and cut it in half? What I tend to do is start with the largest value and divide it in 2. So if I take 180 and I divide it in 2, that gets me to 90. Okay, so that's in between quadrant 1 and quadrant 2, so that's not particularly helpful. But what if I take 90 degrees and I cut it in half? That's going to end up here at 45. So that's completely in quadrant 1. So what I've just shown, I took the largest angle and the smallest angle, and they all ended up in this area here, which is in quadrant 1. So this will end up in quadrant 1 no matter what. And the nice thing about quadrant 1 is that both sine and cosine are positive. So I get to say that sine of theta over 2 and cosine of theta over 2 are going to be positive. Now, the last setup that you need from me for this problem is figuring out how to find cosine. So you're given sine theta equals 4/5, but now you need to find cosine theta. And what I want you to remember is that on a coordinate plane, cosine is equal to x over r, where r is our radius, okay? And we already know this value, it's 5. So what you want to do is use this triangle that we came up with and solve the Pythagorean theorem. So you're going to have x squared plus 4 squared equals 5 squared, and you're going to solve that for x, okay? I'm going to give it away. I'm going to go ahead and just tell you that it is 3. So you are going to have 3, and then if I substitute back in the 5 that we already know, we know that cosine is now 3/5. So once you have figured out the sine value, meaning positive or negative, of your double angles and your half angles, you can use this information of cosine and this information of sine to help you solve the problem. Now, the one last thing that I should mention to be careful with the cosine here is that because we're in quadrant 2, this x is actually negative. So we should have cosine equaling -3 there. Okay, so let's go ahead and take a look at homework problem number 4. Okay, taking a look at homework problem number 4, we're given the cosine, and we know that theta is in between 270 and 360 degrees. So if I draw my coordinate plane again, here's 270, here's 360. I know that my theta is in quadrant 4 to start. So once again, I'm going to give myself a triangle here, create my right triangle. I know that my adjacent side is 3, and I know that my radius is 5. So the unknown value here is y. Okay, so this is theta. Okay, and what we want to do is think about where double theta and half theta are going to land to be able to calculate the sine of 2 theta, cosine 2 theta, sine of theta over 2, cosine of theta over 2. We're going to be able to tell whether these are positive or negative. So this is kind of strange because doubling a value in quadrant 3, like a 2 theta in this case, is going to be quite large. So what I did was I thought about taking, let me erase that really quick. What I thought about was taking an angle like 300 and doubling it. So 2 theta in this case would equal 600 degrees. So remember, 600 is going to be more than one full revolution. So we get to 360 and then we continue on to another 240 degrees. So 600 is coterminal, remember that word, to 240 degrees, which means it ends up in quadrant 3. Okay, but now if I think about taking a bigger angle than that, let's say we take theta is equal to 350. Now if I double that value, 2 theta becomes 700, then I know that 700 is going to be a full rotation plus 340. So this is going to be coterminal to 340 degrees, which is in quadrant 4. Okay, so we know that double theta, when we're starting in quadrant 4, is either going to be in quadrant 3 or quadrant 4. Okay, and if we go back and we think again, right, about cosine and sine being positive and negative in these quadrants, okay, we want to think about what that difference is going to affect. So if I'm in quadrant 3, my cosine's negative, my sine's negative. But if I'm in quadrant 4, my cosine is going to turn to positive. So once again, same as homework problem 2, cosine of double theta is going to be positive or negative depending on which quadrant we end up in. Sine, however, is going to be negative. Okay. Now we want to think about what happens when we have theta divided by 2, taking it and cutting it in half. And again, I kind of mentioned before, thinking about each of these boundary points in the quadrant. cutting them in half and seeing where we end up. So we know 270 is the same thing when we cut it in half, that's 135. And we know that 360 divided by 2 is going to give us 180. So all of these angles, when we cut them in half, are going to live in this little slice, which is in quadrant 2. So we know that the sine of theta over 2 is going to be positive because it's in quadrant 2, and the cosine is going to be negative. Okay. Now the last piece that we should do, we need to look back again at our triangle. The value that we need to solve for is y. So once again, you're going to use Pythagorean theorem, 3 squared plus y squared equals 5 squared. So we know that y is 4. And when I go to write the sine of theta, I know it's going to be over 5 because that's the radius. But because I'm looking at a y in my fourth quadrant, y has to be negative. So I'm going to make this negative 4. So using sine theta, cosine theta, and these positive and negative values, you can now plug all of them in to your double and half angle identities. Here we go with homework problem number 6. So you know the drill. Let's start out by drawing our coordinate plane. We want to think about where our theta lives. So this is saying pi to 3 pi over 2, but let's go ahead and just think about this in degrees because it can often be a little simpler. So we know that our theta is living in quadrant 3, so we're between 180 and 270 degrees. I'm going to give myself a triangle here and a theta. And knowing that I'm in quadrant 3, even though I'm seeing that tangent is 5 over 12, I know that x must be negative, and I know that the y must be negative. So I'm going to make this negative 5 divided by negative 12, which would give us the positive value. So in this case, we're going to have to solve for our radius. That value is unknown to us. So let's start again with 2 theta. Let's think about what's going to happen when we double these. Okay, so I'm going to start with theta equals 200. I want to know where that value is going to end up. Well, theta being 200, that means that 2 theta is 400. So that is going to complete a full revolution plus 40 degrees more. So this is coterminal to 40 degrees, which is in quadrant 1. Okay, but now if I take a larger theta, let's say I choose 260, that 2 theta is going to be 520 degrees, which is coterminal to 160, because it would start here, it would do a full revolution, and it would continue on to 160. So this value would end up in quadrant 2. So now thinking back again, like we've done, what is positive, what is negative in each of these quadrants between cosine and sine? I want to think about what sine 2 theta is going to equal and cosine 2 theta. Okay, so my choices are that I'm either in quadrant 1 or quadrant 2. So quadrant 1 or quadrant 2. And you notice that it is the cosine value that's going to change here. So it's either going to be positive or negative, plus or minus, depending on where our theta lives. And sine in this case is going to be positive no matter what. Okay. The last thing we want to think about in terms of our angle placement is what's going to happen to theta over 2. So this is when we think of our largest value and our smallest value and what happens when we cut them in half. So 270 divided by 2 is 135, and we know that that's this slice right here. And 180 divided by 2 is 90, so that's this piece. So what we found is that all of our half angles are going to live in that little blue pizza slice. And what that tells us, if we're looking at sine theta over 2 and cosine theta over 2, is that our cosine is going to be negative and our sine is going to be positive. Okay? So the last thing that we've been doing on each of these slides is thinking about our triangle and trying to make sure that we have a sine and a cosine value for each of them. So looking back at our triangle, we know our x, we know our y, but we need our r value. So I'm going to set up Pythagorean theorem, where I have -5 squared plus -12 squared is r squared. And I know that you can do this math and follow along, so I'm going to skip a couple of steps because I want to be able to write down the cosine and the sine with you pretty quickly. So I know that r is 13. It's always positive because it's just a radius. So in this case, I know that sine theta is going to equal -12 over 13, and I have that cosine theta is going to equal -5 divided by 13. So armed with these values and these signs, these pluses and minuses, you should be able to go from there. Number 8 is a new type of problem for us. We are going to find the exact value of cosine of 15 degrees using either a double angle identity or a half angle identity. So the thing to remember, theta is always a unit circle angle. So theta is a unit circle angle. And so in this case, we need to think about how we can get 15 to equal a unit circle angle. So immediately what I'm thinking is I know that 15 degrees times 2 would equal 30 degrees. So that to turn this around and be in terms of theta, we could think of this as 30 degrees divided by 2 equals 15. So what this tells me is that I want to use a half angle identity. Okay, so first off, find your cosine of theta over 2 identity. So I'll write that down. Cosine of theta over 2 is plus or minus 1 plus cosine theta all over 2. Okay, theta in this case is going to be 30 degrees. What you've seen from the previous slides is that the plus or the minus in these homework problems all depend on where your theta is located. So theta is in quadrant 1, and theta over 2 is also in quadrant 1. And we know that in quadrant 1, all of these sine values and cosine values are positive. So what I'm going to do is erase this because I know I just need the positive value. So looking on your unit circle, you should find the cosine of 30 degrees, and the cosine of 30 degrees is √3 over 2. So I can start to fill this in. Cosine of 30 over 2 is the square root of 1 plus √3 over 2, all divided by 2. Now this is going to take a little bit of fraction inception and finding a common denominator, but I am very confident that you can take it from here. Okay, this is the last one that I'll go through with you. Number 10 is asking you to verify this identity, and we know that we always try to start identities on the most complicated side. So I'm going to begin with 1 minus cosine of 2 theta divided by sine of 2 theta. So the first idea that I would have is rewriting cosine 2 theta and sine 2 theta using one of our double angle identities. We only have one choice for sine, so I'm going to go ahead and swap that out. I know that sine 2 theta is 2 sine theta cosine theta, and I'll reference this with double angle. Okay. Now I know I have an option for cosine of 2 theta, because you remember we have 3 different things that we can choose. It doesn't really matter which one you pick. However, I might think of swapping out cosine of 2 theta with the middle identity, the one that has a -1, or the last identity, the one that has a +1. Because what I'm really hoping to do is cancel out this 1. So I'm going to choose the last identity and see if it works out. So I am instead going to make this 1 minus 1 minus 2 sine squared theta. And again, this is double angle. Okay, so if I drop the parentheses, I'll have 1 minus 1 plus 2 sine squared theta, because what I did was I distributed this negative sign to both terms. And then on the bottom, I have 2 sine theta cosine theta. So my trick worked. I have 1 minus 1 here, which is fantastic because that goes to 0, and I'm left with 2 sine squared theta divided by 2 sine theta cosine theta. Okay? Remember that your goal is to end up with tangent, but I'm going to leave this for you so you can keep going because I know that you can do it.